Okay, so now that we know a little bit about symmetry, hopefully line reflections will make even more sense. Okay, this unit is a unit on transformations. And a transformation is just, okay, what I've written here, a movement of a geometric figure in the coordinate plane. So on an XY axis, we're taking points or figures and we're moving them in some way. The first one, there's 4 of them that we look at. The first one is called a reflection. And there's a couple different types. We're going to look at line reflections in particular. So this is where that symmetry video comes into play. Okay, we're looking at mirror images of each other. So here, if you look, okay, these are mirror images. This is called the line of reflection. Okay, where it gets flipped over, I guess you could say. So these are just different little examples of lines of reflections. The notation, okay, because there's going to be specific notation throughout this unit for a reflection, is a little r, okay, a little r, a lowercase r, and then whatever the, I'll just put line here, there'll be a subscript. It'll say x-axis, y-axis, or some specific line, and you'll see as we go what that will entail. So the first reflection that we're going to look at is a reflection over the y-axis. So we do have to make sure that we know which axis is the y-axis. Okay, this axis right here is the y-axis. So we're taking this triangle and we're flipping it over here. The easiest way when you have a graph to do this is really just by counting boxes. So meaning if my point A is here at 3, 3 and I count to the line of reflection 1, 2, 3 right here. I don't know if you guys can see that. Okay, I'm having a little bit of issue with my pen. But if I count boxes to the line of reflection, there's 3 boxes away. If I count 1, 2, 3 on the other end, I end up over here, okay, at negative 3, 3. So my A prime, that's how we're going to indicate that it's an image, is negative 3, 3. So I'm going to write that down here. A prime is negative 3, 3. And then if I do the same thing with the B and the C, this is what you end up. So all I did was I counted boxes to the line of reflection and then counted the same on the other side. So this triangle ABC looks like it's flipped over the y-axis. So these are the coordinates of the new image points. Again, this symbol right here, okay, is a prime mark. Okay, it just indicates that it's not the original, it's the image. So if you were to take a minute and actually look at or examine the coordinates, okay, A, 3, 3 became negative 3, 3. 6, 5 became negative 6, 5. 5, 1 became negative 5, 1. And if you thought about what's happening to the coordinates, you would see that there's a rule happening. And if we did this over and over, the same thing would happen. What happens is that when we're doing a reflection in the y-axis, the y value stays the same and the x becomes the opposite. So we say xy becomes negative x comma y. So a reflection in the y-axis, y stays the same, x becomes the opposite. And again, if you need to go back to that last slide to see that, okay, that is true. That is the rule. So if I just take a second and look at these examples, okay, and apply that rule, okay, I would pause it if I were you, try them and see if you get the right answer. So again, the x becomes the opposite or negative, and it doesn't necessarily mean it has to be negative. That's why I keep saying opposite, okay? So this negative really means opposite. Okay, so 1, 4, the 1, because it's in the x spot, is going to become -1, but 4 stays the same. -3, 2 becomes 3, 2, and so on. Okay, so similarly, now we're going to do the same thing, but now we're going to do a line reflection in the x-axis, which is this axis right here. So we're doing the same thing. We're taking triangle ABC, but we're flipping it over this axis, or we're having it look into this mirror. So I'm still counting boxes. So for A, I'm counting 1, 2, 3 boxes to the line of reflection. 1, 2, 3 on the other side. So this is going to be my A prime. And the coordinates there are 3, -3. If I do the same for B and C, this is what I end up with. So your B prime ends up at 6, -5, and your C prime ends up at 5, -1. So again, if you're looking at what happens to the coordinates here, right, you'll see that there's a pattern, which I'll talk about on the next slide. So a reflection in the x-axis, what happens here is that x stays the same this time and y becomes the opposite. So it's exactly what happens in a y-axis reflection. So if I look at each of these examples and I take the x and keep it the same and make y the opposite, I will get the new coordinates. So these are the coordinates we end up with. The next line of reflection we're going to look at is the line y equals x. So if you remember anything from algebra, the line y equals x, okay, has a slope of 1 because that's the number in front of the x, and a b of 0. So this is our y-intercept. This is all review, what I'm talking about over here. So it starts at 0, 0, and it goes up 1 over 1, up 1 over 1. So that's how you know what line it is. Nothing changes as far as how we do it. Okay, because it's the line y equals x, it goes through nicely, and I can kind of count here because we've got some half boxes. I can kind of count. So A is on the actual line of reflection. Anytime you have a point on the line of reflection, it stays the same. Okay, and then B and C really are what we have to figure out. Now, if you look closely, and I know this is small, but if I look at B, it's half a box perpendicular to the line of reflection, because remember, we're flipping this over. Okay, and then it's another half a box on the other side. So, again, this is hard to do, but we end up at 5, 6. And then for C, the same thing. If I count diagonally, that's 1, this is 2 diagonal boxes, 1, 2. And now I know I said the other day that you should never count diagonally, okay, but here, because it's the line y equals x, we kind of can. Okay, we end up right there. Okay, hopefully you can see that. And then C ends up at 1, 5. So if you examine these coordinates, you'll see what's happening. Okay, 3, 3 went to 3, 3. 6, 5 went to 5, 6. 5, 1 to 1 to 1, 5. So there's a rule that's happening, which we'll discuss on the next slide. Okay, so the rule here, I went ahead and filled it in, is xy becomes y, x. They just switched. So 5, 2 becomes 2, 5. -4, 1 becomes 1, -4. B, 3a, -b becomes 3, -b, 3a. They just switch spots. So what I'm actually going to do, because this is already a pretty long video, I'm going to separate this in and I'm going to put the next 3 slides. You'll see they'll be blank. I'm going to put them into a new video. So these are not going to be part of this video. I'm going to make a separate one because it's just too much. It's too long of a video. Okay, hopefully that's okay. All right, guys. So complete the assignment that goes along with this, and hopefully it's not so bad.